All right, we are reviewing inequalities here. We've got another review day tomorrow before our test on Wednesday. You got to know 3 different kinds of inequalities. You got to have 2 variable, which is here on a graph, 1 variable, which is not on this review, but that's where you got the number line with your open or closed dot, and then shade in one way or the other. And you're going to have word problems down here at the bottom and on the back. So let's jump straight in to number 1 here, 1A, I guess. There's 3 number 1s. With y is greater than 2x minus 5. I see this is already in mx plus b form. I know my m is 2, my b is negative 5. You begin with your b. So count down 5, that's my starting point. I gotta look at my slope. I need that to be a fraction so I can see rise over run. I'm going to rise up 2 and run over to the right 1 to figure out the pattern of my line. It's going to look like this. Once I know that, do not draw your line on there yet because you have to look at your symbol greater than here. That tells you what the line looks like and where your solutions are at. So where to shade, in other words. There is no equals to on here, just greater than. Since there's not an equal to, I cannot draw, oh good lord, that's terrible. I cannot draw a solid line like that. The solid line shows equal to, it is not equal to, so I need to leave it as a dashed or a dotted line, like that. That shows that it's not equal to the line, only greater than the line. Only greater than the line, well the greater side is above the line. So, shade above the line. Those are all solutions. What that means is any ordered pair that is in this shaded region, 2, 4, for example. If I take 2, 4, that's the x and that's the y, I can plug in the 2 for my x, and I get 2 times 2 minus 5, and that will be true when I plug in 4 for the y. So 4 will be greater than whatever the 2x minus 5 is. In this case, we get 4 is greater than 4 minus 5 is negative 1. That is true. I knew that was already going to be true because 2, 4 is in my shaded region. If I took a point from outside my shaded region, let's say 1, 2, 3, 4, 5, comma, negative 2. If I plug in a 5 for my x and a negative 2 for my y, that will not be true. That's a 2 there. Negative 2 is not greater than 5. I knew it was going to be false though already because that point came from outside the shaded region. So you can find solutions on a graph by looking where it's shaded. You can find solutions in an equation by just plugging in the x and y. So that kind of summarizes a lot of what may or may not be on the review, may or may not be on the test. There are some questions later on that ask about that, but just wanted you to see it up front and have that in the back of your mind as you're going through the rest of the review. Get rid of that so I can leave just the answer. There we go. Okay, answer number 1. Let's go look at number 2 now. We'll jump to red. Y is greater than or equal to 1/3 x plus 2. Again, it's already in mx plus b form. B is plus 2. 1/3 for my slope tells me to rise up 1 and run over 3. Right there. Continue going up 1 over 3. Continue going down 1 over 3. That gives you the full image of what our line will look like. So now I have to look at my inequality symbol. Greater than or equal to. The equal to here tells me I do get to draw the solid line. And again, greater than is everything above that solid line. So now, what if I asked you, is this point 3, 3 a solution or not? Well, you could plug in the x and do all the math, but I know it is on the solid line. It's going to give me a y that equals the rest of it on a solid line that is a solution. What about back over here at this one? What if I asked you 1, 2, 3, 4, 3? Is that a solution or not? Well, it would give me an equal to, which in this case is not a solution because it doesn't include the equal to line. So, on a solid line is a solution, on a dotted line is not a solution. There we go. Number 1C, we have y is greater than 6. This is a weird looking equation, but it is in fact in mx plus b form. You just can't see 0x plus 6. That's what it really looks like. That tells me my y-intercept is 6. Put the dot there. My slope is 0 over 1. If you don't remember what a 0 slope looks like, think of it like this. Rise up 0, run over to the right 1, and it's going to give you a solid line that goes perfectly horizontal. 0 slope is a horizontal line. Less than here, though, tells me where how my line looks and where I shade. No equal to, so not a solid line, just dotted. And less than tells me to shade everywhere below the line. So there's number 1, A, B, and C. Number 2, A, B, and C. These equations are not in mx plus b form. We have to put them there. So start with 5x minus y is greater than 6. I want to isolate the y, get it all by itself. So start by minus 5x, subtracting 5x to both sides. Don't lose the negative sign that's in front of your y here. Negative y is greater than negative 5x plus 6. I don't want negative y, I want positive y. So I need to get rid of this negative 1 here. Divide by negative 1. That gives me y is anytime you divide by negative 1, or negative anything, any negative number, you have to flip your inequality around. Greater than becomes a less than positive 5x minus 6. So now we have our graph, our equation. We can go ahead and graph it. Start at negative 6. 5 is 5 over 1. That's my slope. So up 5 over 1. Go back to purple. Up 5 over 1. Up 5 over 1. So there's my line. Very steep line. Less than tells me a dotted line and shade below the line. 1 or 2b, 3x plus 9y is greater than 0. We need to get the y isolated again. Minus 3x to both sides. 9y is greater than or equal to negative 3x. Divide both sides by 9. And you get y is greater than or equal to negative 1/3 x. We didn't divide by negative, so we don't need to flip anything around. Now we divided it to a negative number, this negative 3, but we divided by positive 9. We do not need to flip anything around. My y-intercept here is plus 0. So we start at the origin, and my slope is negative 1/3. So down 1 over 3, down 1 over 3, down 1 over 3, greater than or equal to, tells me solid line, shade above. 2c, 4x minus 2y is less than or equal to 8. Get the y isolated. We have minus 4x to both sides. Negative 2y less than or equal to negative 4x plus 8. Divide by negative 2. Should be sirens going off in your head. Dividing by negative number. Uh-oh. y is greater than or equal to, switch that around because of that negative number, negative 4 over negative 2 is positive 2x minus 4. Start at negative 4 and go a slope of 2 over 1 and greater than or equal to tells me solid line, shade above. I'll show you a little trick on this one. Might help you out a little bit on the test. Your calculator, remember this, y is greater than or equal to 2 over 1x minus 4. Your calculator can graph. So let's look at a calculator. Here we go. New document. I want to open up a graph page here. We used the relation graphing a while back where we erase the equal sign. Look at what pops up when you erase the equal sign. Y is greater than or equal to. I believe number 5 is what our problem was. Yes, y is greater than 2x minus 4. So y is greater than 2x minus 4, and that gives us a solid line. Now, sometimes the line always looks solid. You got to click around a little bit. Solid line shaded above. Sometimes it appears a little bit solid even when it's supposed to be dotted, so be careful there. But it does definitely give you a good image of what your line should look like. Another trick: if we go to a new graph and delete the equal sign, we can choose relation, option 6, and we could type in the original problem the way it was given to us. 4x minus 2y is less than or equal to 8. So I can type in 4x minus 2y. Now, less than or equal to. You got to look over here above control with control. Control equals is going to give you your options. No, it was less than or equal to. Less than or equal to. Oh, shoot. Come on. There we go. 8. Hit enter, and it gives us our graph. So, depending on how the question is worded, that could give you your answer, or it could help check your answer. Use that however you see fit. Down at number 3, in order for a student to be considered for a certain college grant, the combined income of the student's parents must be no more than $35,000. Just from that alone, no more than means not more than, means it's got to be less than. Equal to is still not more than, so equal to also works. 35,000. That is no more than 35,000. Well, what is it that has to be no more than 35,000? The combined income of their parents. So if we're going to use F for the father's income, M for the mother's income, how do we combine their two incomes? Well, with a plus sign. M plus F has to be less than or equal to 35,000. That is your inequality. We can't solve anything with two variables, so we just leave it like that. Number 4, Mike sells used cars. He makes $250 per week. So, important here, per week might be important, plus $200 for each car. That could also be important. Because of his cost of living, he needs to earn at least $1,250 per week. So we're looking per week here. So every week he has to make this amount. So we're not going to be multiplying how many weeks it is because it's every week. So for this week right now, he's going to earn $250 plus $200 for each car. 200x. That has to be at least, which is greater than or equal to 1,250 to pay all his extravagant bills. How many cars must he sell each week to accomplish this? Write the inequality and solve it to find your answer. We wrote the inequality. That's this. Now we just need to solve it. So I want the x all by itself. Get rid of 250. And we have 200x greater than or equal to 1,000. Divide by 200. And we end up with x is greater than or equal to 5. So as long as he sells 5 cars or more, he will be able to afford his extravagant bills. Number 5, at a local electronics store, CDs cost $7, DVDs cost $20. Problem's a little outdated. CDs cost 7, DVDs cost 20. Write an inequality to describe the number of CDs, X. So I'm going to call that X, and DVDs, Y, that can be purchased for $75 or less. So that means it can equal 75 or it can be less than 75. I can't go over 75 because I don't have enough money. So how many CDs can I get? Well, there's 7 each, so 7x. How many DVDs? Well, they're 20 each, so 20y. That has to be less than or equal to 75. Number 6. Create an inequality that meets the following conditions. Solutions are going to be 3, 7. That is here. 8, -1. So 1, 2, 3, 4, 5, 6, 7, 8. -1 is there. -4, 6 is there. These are solutions. So what I know about solutions is that they need to be in the shaded region. Non-solutions, let's switch to red for those. -7, 3, 3, 4, 5, 6, 7. -3, oh, +3. That is a non-solution there. 2, -8, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8 is a non-solution there. So those are in the non-shaded area. So now we need to create an inequality, go with green, that meets those conditions. So we need to make a line, make an equation, where the blue dots are shaded in and the red dots are not. So there's an infinite amount of right answers here. I'm going to look at what I think might be the easiest one, and that's if I make a perfect diagonal line with a slope of -1, down 1 over 1. My y-intercept is right there at 0, so I'm going to say y is not equal to. Don't say equal. Can't say equal to because we're looking for an inequality. I need it to be an inequality with a less than or greater than. Well, I know it has to be greater than. If I want the top shaded in, that's greater than. I drew a solid line, so I'll make it equal to. I very easily could have had a dotted line here, and it would still be just as good. I can erase the equal sign, but I want the solid line. I want it equal to. mx plus b. I have my m down 1 over 1, which is -1 divided by 1 is -1. So -1x, or just -x, plus b, well, my y-intercept is 0. So I don't need anything there. Put plus 0. It's not necessary, though. Mine, like that. So y is greater than or equal to -x. That creates this green inequality, which makes those solutions and those not. Number 7. Circle the points that are solutions to the inequality 2x plus y is less than or equal to 6. This would be easier with a graph. Well, your first instinct is probably to look at that and graph it, but we don't need the graph to find inequality or to find solutions. We can look at the x and the y value and plug it in. My equation says that 2 times x plus y has to be less than or equal to 6. Well, if I plug in a 5 to my x and a 9 for my y, that's 10 plus 9, which is 19, is greater than or equal to 6. I'm sorry, less than or equal to 6. That is not true. 19 is not less than 6. So that's not a solution. -1, 4. -1 is my x value. So it goes there. 4 is my y value. It goes there. If I do the math, I have -2 plus 4 is less than or equal to 6. Well, that gives me 2 is less than or equal to 6, which I know that is true. So circle that. 12, -12. I'm going to plug in 12 for my x, -12 for my y. See what happens. 12 for x, -12 for y. We get 24 plus -12 less than or equal to 6. 12 is not less than or equal to 6. No. Last one, 15, -30. We're going to do this one a little different. I've done the last 3 here. I think you get the idea there. We'll do it a little bit different. Plug in the x for 15 for the x, -30 for my y, and let's go look at our calculator. I'm going to add a new page, make it a calculator. I'm going to say this right here, 2 times 15. 2 times 15 plus -30, is that right? Plus -30 is less than or equal to 6. Well, remember your inequalities are there, control equals. Let's say is less than or equal to 6. You hit enter, it comes up true. That is true, which means it is a solution. So yes. 2 solutions, 2 non-solutions. With the calculator or without, there's multiple ways of figuring that out. Last one, number 8. April claims that 2, 15, 0, 1, and -1, 7 are all solutions to the inequality y is greater than 5x plus 1. Is she correct or is she incorrect? Why or why not? This is very similar to number 7 up above. Are these solutions or are they not solutions? You can plug them in to figure it out, or you could use your calculator to figure it out. I showed you both ways up above. I'm going to do a little of both ways here. 2, 15. Remember, this is my x and this is my y. So April is claiming that y, which is 15, is greater than 5 times x, which is 2, plus 1. 5 times 2 plus 1, that's 10 plus 1, that's 11. 15 is greater than 11. That is true. So far she's right on at least 1 point. Instead of plugging in 0, or 0, 1, and -1, 7, we're going to look a little different way here. I want to go back to my calculator and graph y is greater than 5x plus 1. So add a new page, make it a graph, delete my equal sign, y is greater than 5x plus 1. So choose 4. Uh-oh, that's not what I went to do. Let's go back to a new graph. Delete the equal sign, choose 4, y is greater than, there we go, 5x plus 1, enter. See, this is what I meant earlier. The line appears to be solid. Kind of move your mouse around a little bit, it highlights that line to make it look solid when in reality it's not. So now we can see that the line is dotted. I want to look at where these ordered pairs are. I want to look at where 0, 1, -1, 7, and 2, 15 are. So go back to your calculator, menu, view, option 2, grid, option 6, and aligned grid, option 3. Now I can see where some of my coordinates are. Let's go look at, what are we looking at? 0, 1. I have 0, 1 is right here on my y-intercept, on my line. What do we know about dots on the line? Are they solutions or not? Well, here the line is dotted. That's going to end up being equal to, I would get something like 1 equals 1, or sorry, 1 is greater than 1. That is not true. Uh-oh, April. 2, 15 is a solution, but 0, 1 is not. Let's check -1, 7 just to see. If I look at -1, 7, I go to the left one, 1, 2, 3, 4, 5, 6, 7. It's a little bit off the graph, but I know up there it's clearly going to be in the shaded region. So that one is a solution. 2, 15, we already know it, but if we look at the graph, to the right 2, 1, 2, 3, 4, 5, 6. Keep going all the way up to 15, and that's a hard one to do. It may or may not be in the shaded region, I'm not sure. So this method may not be the best for this problem, but actually, you know what? Now, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like 11 is right on the line. Anything above that is shaded. So may not work the best for every problem, but this can definitely help you out on some problems. That's what I wanted to show you here. It's just another technique of getting these answers. You can do this 3 or 4 different ways. But because of that one, April is wrong or incorrect. Because 0, 1 is not a solution. So, sorry, April. You have your test on Wednesday. Hopefully this clears up any questions you may have had. Good luck.